Bismillahirrahmanirrahim. Dear students, in today's class we will learn bubble sort algorithm. As usual, I will begin with an example in order to understand how the algorithm works. Then I will design algorithm for you, and then we will find the complexity of the algorithm. So let's begin with an example in order to understand bubble sort algorithm. For example, we have numbers like 4, 2, 5 and 1. We want to sort the sequence of number using bubble sort procedure, using bubble sort algorithm. So how bubble sort algorithm works? It begins with the first number. Compare the first number with the second number. If, for example, the first number is larger than, greater than the second number, then we will swap the two numbers and we will continue this process up to the last number. So we will choose the first number and we will compare it with the second number. As 4 is greater than 2, so we will swap the two numbers. 4 with 2, we will get 2, 4, 5 and 1. And then we will choose the next number in the sequence, that is the second number, and we will compare it with the third number. 4 is not greater than 5, so we will not swap the two numbers. So the resultant sequence is 2, 4, 5 and 1. Now we will move to the next number in the sequence, that is 5. 5 we will compare it with 1. So by comparing 5 with 1, we see that 5 is greater than 1. So we will swap the two numbers. And the resultant sequence is 2, 4, 1 and 5. And this is called first pass, pass number 1, or first pass, pass number 1 of the bubble sort algorithm, in which the first largest element moves to the last position or bubbles up to the last position. That's why the algorithm is named as bubble sort algorithm, because in this algorithm we compare each two consecutive numbers, a number with the next number in the sequence, and if the number is greater than the next number in the sequence, then we swap, we change the two numbers, and in this way the first largest element moves to the last position. Now we begin with the second pass. Again 2, 4, 1 and 5, we have this sequence which is the result of the first pass. We again begin with the first number in the sequence, 2 with 4, as 2 is not greater than 4, so we will not swap the two numbers, not change the two numbers. The resultant sequence is 2, 4, 1 and 5. Now we move to the next number in the sequence. 4 will be compared with 1 because 4 is greater than 1, so we will swap the two numbers. 4 is changed with 1, so the resultant sequence is 2, 1, 4 and 5. Now we move. That's it, because the second largest element is 4. It is moved to the second last position, so there is no need to compare it with the last number, because last number is already the largest number which is moved to the last position by the first pass. So this is pass number 2 of the bubble sort algorithm. Now we begin with the third pass. In the third pass, again we start with the first number in the sequence. 2 will be compared with 1, as 2 is greater than 1, so we will swap the two numbers, and the resultant sequence is 1, 2, 4 and 5. That's it. The third largest element, that is 2, is moved to the third last position, and that's it. Now this is the sequence is now 1, 2, 4 and 5 is now in sorted form. Now in order to design algorithm for this bubble sort procedure or method or approach for sorting a sequence of number, we need to understand some facts in this example, some important things in order to design the algorithm. So as how many passes are there? This is pass number 3. How many passes are there? There are 3 passes. And how many numbers we have in the sequence? 1, 2, 3 and 4. So for 4 numbers we have 3 passes. For 4 numbers we have 3 passes, because for 4 numbers we have used 3 passes. In 3 passes 3 elements are moved to their correct position. If we have and the element and the 4th element, it will be automatically in sorted form if 3 out of 4 are moved to their correct position. If we have 4 numbers, 5 numbers, then moving 4 numbers on their correct position, we will get all the 5 numbers in sorted form. If we have 10 numbers, then moving 9 numbers to their correct position, we will get all the 10 numbers in sorted form. So similarly, for 10 numbers, how many passes are required? 9 passes are required. 9 passes are required for 10 numbers. We have 4 numbers. For 4 numbers we needed 3 passes. So if there are n numbers, how many passes will be required? Of course n minus 1, because 10 minus 1, that is 9 passes are required for sorting 10 numbers. For sorting 4 numbers we needed 3 passes. Similarly for sorting n numbers we will need n minus 1 passes. So in bubble sort algorithm, the number of passes is equal to n minus 1. That is, the total number of elements minus 1 will be the number of passes. Now another important thing that we need to understand is the number of comparisons, because in each pass the number of comparisons are vary. In the first pass we have done 3 comparisons, 1, 2 and 3. We compared 4 with 2, we compared 4 with 5, we compared 5 with 1. That's it. In the second pass we did how many comparisons? 2 comparisons, 2 with 4, 4 with 1. That's it. In the third pass the number of comparison is only 1. We compared 2 with 1. That's it. So it means that the number of comparisons also vary. So we will derive a general form for the writing or generalizing the number of comparison. So in the first pass the number of items is 4 and the pass number is 1. Pass number is 1, and how many comparisons we did in the first pass? 3 comparisons. Similarly in the second pass the number of items is again 4, and the pass number is 2, and number of comparisons is 2 in this case. In the third one, the total number of items is 4 and pass number is 3. Pass number is 3 and number of comparison is 1. Number of comparison is 1. If we see the relationship between the total numbers, the pass number and the number of comparison, so we can see that if we subtract 1 from 4 we will get 3. If we subtract 2 from 4 we will get 2. If we subtract 3 from 4 we will get 1. It means that if we subtract pass number from the total number of items or elements, we will get the number of comparison. In the first pass we did 3 comparisons, so total number of items minus pass number gives us the total number of comparisons. Similarly in the second, pass number 2 is subtracted from the total number of items, we have 2 comparisons. Similarly in pass number 3 we have 1 comparison, that is 4 minus 3, the total number of items minus 3, we will get the number of comparisons. So we can generalize this thing. If for example the number of items is n and we subtract pass number from this, so we will get number of this gives us number of comparison in that particular pass. So we have derived, we have generalized two things. How many passes will be required? We will need n-1 passes. And the second thing, the number of comparisons in each pass, that is n- pass number will give us the number of comparisons in each pass. Now we will derive, we will design the algorithm for bubble sort. And there is another important thing to understand, that because we know the number of passes and the number of comparisons in advance, we can determine this thing. This is already known. If we have 5 items, we will need 4 passes. And if we are in pass number 3, then 5 minus 3 will give us the total number of comparison, that is 2. So this can be determined in advance. Anything that can be determined in advance, for that, and if there is a repetition, so for that we will use for loop. So because we are doing this repetition, look, comparison, we are doing this repetition, the first pass, again starting from the first item, and comparing items, again starting from the first item and comparing items. The number of passes are known in advance. The number of comparison in each pass, these are known in advance. So we will use 2 for loops for this purpose. So the first one is for I equals to starting from 1, because always we begin whenever we start the bubble sort algorithm, we will begin comparison from the first item. So for I is equal to 1, 2, how many passes we will need? n-1. We will generalize this thing, and then we will apply this on the algorithm. This will control the number of passes starting from I is equal to 1, then I is equal to 2, I is equal to 3, and so on up to n-1. n-1 passes we will need in this algorithm. And then what we do, we begin from the first item and we compare it with the second item. So again we will need another loop for, and j is equal to, let's suppose j is equal to again from 1, and this equals to what? Number of comparisons. How many comparisons we will need? So this is n minus, the pass number is there in I. If I is equal to 1, that we are in the first pass. If I is equal to 2, we are in the second pass. So n minus I, this will tell us the pass number. Pass number, I is pass number, n is total number of items. So n minus I means total number of items minus pass number. This gives us the number of comparisons. So it will begin from j is equal to 1 through the total number of comparisons. So I am designing algorithm for you. Now we say, if for example the first item that is there, let me make this as an array. This is an array. Suppose this is an array A, 1, 2, 3, 4. These are the indexes of the array A. We will compare 4 with 2. So in this for loop we say, if for example, if a of j, the first item is greater than the second item, is greater than the a of j plus 1. If this is the case, then do what? Swap the two items. If this is, for example, if the first item is not greater than 2, then do not swap it. So we are doing a comparison over here. So for comparison, we have used the if statement. If a of j value is 1, a of 1 means the first item is greater than a of j plus 1, then swap the two items. And you know this better, how to swap the two numbers, how to swap the values of two variables. So in order to swap the values of two variables, we need a third variable, a temporary variable, where we store the value of the first variable, then we assign the value of the second variable to the first one, and then the value from the temporary variable is assigned to the second variable. So one variable over here is location aj and another is a of j plus 1. If, for example, this first number is greater than the second number, so we will need a temporary variable, and there we will assign a of j. And now a of j is available for us, so a of j is assigned what? A of j plus 1. A of j plus 1 value is assigned to the first variable, and now to a of j plus 1 we will assign the value that is stored in the temporary variable, that is the value of a of j. So in this way it will swap the two numbers that are being compared in the first comparison. After the ending this end of if statement, end of if, it should go to the next comparison. So we should end the second for loop over here, second end of second for loop, and after doing all the comparisons, our algorithm should go to the next pass. So we should end the first for loop. This is step number 4, 5, 6, and so on. We can give number to these statements, and we can write consider this as the last statement as well. So now I have designed an algorithm for you from the example, but I am not yet sure whether the algorithm is okay, correct or not. Now we will execute this algorithm on this example, and if, for example, if it sort our this sequence of number correctly, so it means the algorithm is working correctly. So let's begin with the first statement. For I is equal to 1, so the value of I is set to 1. I is used as a loop counter variable, so the value of I is sorry, one minute please. I is declared as a variable. I is initialized in the first for loop. I is initialized to 1, and it will be executed. This loop will be true up to n-1. In this case, the last item of the array is 4. The index is 4. So 4 minus 1. this loop will be executed for 3 times, starting from 1 to up to 3, because the number of passes are 3, so this loop should be executed for 3 times. So now because I is equal to 1 and 1 is less than 3, so the condition is correct. Loop will be executed for 1, the value of I is 1, so it is true, it will be executed. When the value of I becomes 2, so this condition, this loop will be executed for the second iteration. The value of I is equal to 3, it should be executed. When the value of I becomes 4, so it should exit, because the first for loop is true for 1, 2 and 3 values. Now in the second for loop, when the control comes to the second for loop, then j is initialized to 1 as well. J is initialized to 1 and it will be executed up to n minus I, n value of course that is 4, the value of I is 1, so n 4 minus 1, so this will be executed from 1 up to 3. Now because this is also the condition is true, so this for loop will be executed. The second for loop, this is the body of the second for loop. Within the body we have an if statement. If a of j, the value of j is 1, a of 1, what is it? A of 1? A of means array A at 1th location. What we have? Array in array A at 1th location we have 4. So we have 4 over here. 4 is greater than A of j plus 1. The value of j is 1. 1 plus 1, it makes 2. A of 2 in array A at second location at index 2. What we have? We have 2. So 4 is greater than 2. Yes, of course, 4 is greater than 2. This if condition is true, so we will perform this statement. This is within the body of this if statement. These statements are associated with the if structure. So now temp is another variable. Temp is another variable and it is assigned a of j. J value is 1, a of 1. At a of 1, what we have? We have 4. This is assignment operator. It will take the value of 4 and store it in temp. So temp will be assigned value 4. Now a of j, j value is 1. Each time when you are using a variable, so check its value in the memory. These are our memory locations, so we will take memory from these locations. J value is 1. This method, believe me, this method, if you follow this method, if you execute your program, if you execute your algorithm in this way, you will like make your logic. This is a way to develop your logic. Logic is a skill, it can be developed. So for this you have to execute the algorithm in this way. So a of j value is 1 at 1th location of array A. What we have? We have value 4, so 4 is assigned to temp. Now a of j means a of 1. This location is assigned a of j plus 1. J value is 1. 1 plus 1, 1 plus 1, that is 2. A of 2, what is it? A of 2, we have 2. 2 is assigned to a of 1. 2 is assigned to a of 1. Now a of j plus 1, j value is 1. 1 plus 1, 1 plus 1, that is 2. A of 2, at a of 2 we are assigning temp. Temp contains 4, so 4 is assigned to a of 2. A of 2 is assigned what? 4, value 4. Now this is the end of if statement. After this statement we have the end of this, the second. This is the second for loop. This is being ended, but before exiting the second for loop it should check the condition. So because this is for loop, so the loop counter variable will be incremented. J is set to 1. Now it is incremented by 1. It becomes 2. Now 2, this is the loop will be executed for 1, 2 and 3. So 2 for 2, this is true, so it should be executed. If again, now the if statement will be executed. If a of j value is 2 now. What is at a of 2? We have 4. At a of 2 we have 4. At a of j plus 1, j value is 2. 2 plus 1, this is 3. At a of 3 we have 5. So 4 is greater than 5. No, the condition is false. This if body will not be executed. Now the control again will go to the loop condition. This is for loop, so loop counter variable will be incremented by 1. It becomes 3. The loop is true for 3. So now again if statement will be checked. A of j value is 3. What is 8a of 3? At a of 3 we have 5. At a of 3 we have 5 is greater than, again j plus 1, j value is 3, 3 plus 1, 3 plus 1 is 4. What is at a of 4? We have 1. 5 is greater than 1? Yes, the condition is true because 5 is greater than 1. So now condition is true if statements will be executed. Temp is assigned a of j, j value is 3. At a of 3 we have 5. 5 is assigned to temp. Temp contains 5 now. Now a of j value is 3. What is at a of 3? A of 3? A of j, a of 3 means this location is assigned a of j plus 1. J value is 3. 3 plus 1. 3 plus 1 is 4. At a of 4 we have 1. So 1 is assigned to a of 3. 1 is assigned to a of 3. 1 is assigned here. Now a of j plus 1, j value is 3. 3 plus 1 means 4. At 4th location we will assign temp. Temp contains 5s. 5 is assigned to a of 4. 5 is assigned there to a of 4. Now look, this is after exiting this if statement, it will go to the condition again. J value will be incremented. It becomes 4. 4, this is now the condition is false because this loop is true for 1, 2 and 3. That's it. So it will, the condition is false, so it will go outside of this second for loop. So this is now the end of the first for loop, but the control cannot exit from the first for loop. It will go to the incrementation decrementation. The first for loop, I value is 1, it will be incremented to 2. Now this is the beginning of the second pass. Now look, the first pass is finished and the result of the first pass is 2, 4, 1 and 5. 2, 4, 1 and 5. 5 is the first largest element that is moved to the last position. Now when the second pass is executed, it will move the second largest element, that is 4, to the second last position. Now look, this is the 2, 4, 1 and 5. This is the result of our example, and the algorithm result is this one here in this array, that is 4, 2, 4, 1 and 5. They are exactly same. 2, 4, 1 and 5. It means the algorithm is working. Now for complexity, in order to understand the complexity of the algorithm or the analysis or the running time, how much time the algorithm will take, for this we have a class, and check the video for the analysis of bubble sort algorithm. Thank you very much.